So first order differential equations most of the time can be solved using what's called separation of variables. Now, really important to identify something here. In order for separation of variables to work, there needs to be some sort of multiplicative relationship between the x and the y. So if it's not one, you got to turn it into one, otherwise it's not going to work. And it may not work. There may be situations where this doesn't work. But the idea is if you have some function of x and some function of y, and you'll see some examples in a little bit, such as like this one right now, and in the future videos, you can just divide everything with a y to the other side and multiply everything with an x to this side. So what ends up happening is we would have on this one dy over the function, whatever function is of y, and then equals our function of x dx. I'm going to multiply this dx to the other side. And you're going to see a bunch of examples of this, and then we'll integrate both sides, and that'll get us our solution for y after we solve for y. So, not a big fan of this first assignment. I prefer the second assignment. It'd probably make more sense. So if you don't get this first assignment, it may help to watch the second video first and then come back to this one. So if you don't get this assignment that we're currently on, which is this one, maybe skip down, watch this one, see some examples of this, and then return back to this one. And it's probably going to make a lot more sense. And then after that, this one follows well after those two assignments. So it's really just this one I feel is out of place. So Daniela tried to solve the differential equation. So she's going to go through her steps of solving this. So in order to move this term that has a y, and you can see the multiplication. See how this is like our f of x here? This is our function of x, and here's our function of y. Just like we saw up there in that example. So we have those two functions. Excuse me. So what I'm going to do is I'm going to divide this e to the y to the other side. So let me just copy this real quick. I'll show you how you're supposed to do this, and then we'll check and see what Daniela did. So I'm going to divide by e to the negative y. And similarly, dividing it is multiplying by the reciprocal. And so what we're also going to do is multiply the dx to the other side. Kind of a strange move. And so what we're going to have on this side is we're going to have 1 over e to the negative y, because I divided by e to the negative y, dy, equals 2x dx. So that's the goal. We separated the variables. We divided the one with the term with the y to the left side, and we multiplied the dx to the other side. So now what I'm going to do is I'm going to go ahead and put an integral sign. Now in order to integrate this, let's bring it up to the top. And then when we do that, it becomes an e to the positive y. And now we'll be able to integrate it. Now let's just check step 1. It looks like we did the separation. We divided the e to the negative y, but hold up. In order to bring e to the negative y to the top, it's got to become a positive y. So all they did was just move this e to the negative y to the other side, but you got to realize in order to do that, we have to divide it. So when we do that and then we bring it up to the top, it becomes a positive y, and that's where we'll see the mistake on this one. So it's actually in step 1. From there, you do the antiderivative. That would be correct, actually, for the antiderivative of this, not for this. Antiderivative 2x is x squared, and then you have plus c. Divide the negative, but remember there shouldn't be a negative, and it should be a positive y. And the rest of the solution is probably correct, and we'll go through those solutions in the next video of how to solve things like this. Let's take a look at this one real quick. So what we have here is, I'm going to go through the steps again, how I would go through it, and then we'll check. That's what you might as well do the next assignment before even doing this one. So I'm going to divide the y to this side. I'm going to leave the 2 though. Let's leave it with the cosine. I'm just going to divide the y. So that's multiplying by 1 over y, same thing. And then multiply the dx. put a little space here so I can integrate. And let's check it. 1 over y, 2 cosine of x. That looks good to me, so I'm going to just put a check mark there. So step 1 is good. Let's take a look at step 2. So how do we integrate 1 over y? Well, that becomes natural log of y. We're not going to put plus c. We're just going to put 1c on the right side. So that's going to equal 2 sine of x. And then plus c, our constant of integration. Very important for differential equations. In order to find it, we have to have an initial condition. This is actually called, we're working on getting the general solution. So, looking at this, step 2 is missing that plus c. So right there, it's missing that plus c. So that's where this one went wrong. Now let me go ahead and take you through the rest of the solving method. Obviously, that's what the next video is about. We're done at this point, but what would be next? Let's just say they had that correct. What would be next? So what we would do next is we would, to get rid of natural log, I want to make everything with the base of e. And what we do with one side, we got to do to the other. So the e and natural log cancel out, leave us with y equals, and then we'll have e to the 2 sine of x plus c. Kind of an interesting step here. So 2 times c is c, because we don't know what c is. It's just some arbitrary constant, and it just kind of absorbs anything that's done to it. 2 times c is c, c squared is c, e to the c is also c. Anything with this constant is c. And when we get to the particular solution, we have to substitute. You'll see what I'm talking about. We'll go in more depth of this and how and the reason why this absorbs it in the end. But for now, just realize any operation that's done to c, like it doubling it, anything that you saw here, it's just going to be c. So what I can do is if you have a number at the same base, like let me do something a little more like x squared times x cubed. We know that we add the exponents, right? X to the 5th. So what would prevent me from splitting up x to the 7th as x to the 3rd plus 4, which would be x cubed times x to the 4th, right? I could split up a 7 so many different ways. So I could split up as two numbers being multiplied together with the same base, and we add the exponent. So I'm going to do that. Since this is adding, wouldn't that be the same thing as e to the 2 sine of x times e to the c? And this is what you're going to typically see when you see things in this e form. And then we're talking about e to the c is just c. So it becomes c e to the 2 sine of x. And who knows? It's probably good to go over that in this video because maybe they do carry it all the way down to the solution correctly in one of these problems. But that's the idea there. A lot of times when we deal with these exponentials, that's what's going to happen. You're going to be like, where did that c come from right here? And it's because they split it up as e to the 2 sine of x times e to the c. Why wouldn't it just be plus c at the end? Because that's different. That's adding to the exponential. This is really part of the exponent, which ends up being a multiple to our exponential function there.